to dimensioning architectural projects. And then if you have any questions about Chapter 5 too, if you're having trouble getting those dimensions on there for some reason, and that's why you haven't submitted them, please stay on and talk to me or send me an email, and let's have a one-on-one meeting and let me help you out with that. Okay, so I'm going to record what we're doing today, and I will post this at the recorded class meetings in Blackboard. So the first thing I'm going to do is, let me see here. I want to present to your screen. So I'm going to move this guy out of the way, and I'm going to get my, hopefully, there we go. Takes me a second to get all this stuff set up. And so I'm going to present to your, hopefully to your entire screen now. Here we go. So you may want to set your screen to where you're seeing full screen so you can see what's going on. Right. And in fact, that's what I'm going to do to mine too, so I can see what full screen. All right. So dimensioning architectural drawings is not as complicated as dimensioning mechanical drawings. And so I'm just going to quickly kind of run through some of how this works in an office. So if you go to work for an architect or in an architectural office, there's probably a designer, and could be an architect, who's coming up with all the designs, and then they hand that design off to you as the drafter, and you're expected to set it up in their CAD system and use their layers and any rules that they have in place for creating the drawings. And then these drawings are going to go out to contractors, they're going to go to permitting, and so they're really an important thing. And so drafters are very important to these architectural firms, and these are good jobs to be a CAD technician at a big firm. And architecture covers so many things. Like, there are some companies that hire out of our department here at ACC who their entire company is all about doing the custom glass that goes on these high rises that you see downtown, or smaller commercial projects. But nevertheless, you can imagine doing glass for a high rise. That's a big deal. And so there are companies that specialize in all kinds of things. There are companies that specialize in fire alarms and safety systems. There are companies that specialize in plumbing, and companies that specialize in electrical. And for each of those, they have to make CAD drawings. So there's a lot of work involved for a good CAD technician. And even though you may start out as a CAD technician, there's always the possibility of working your way up into a design position once you get some experience. So I really think it is a good opportunity. Architecture and civil probably have the most jobs in the Austin area because of the fast pace of the growth around here. But just like on a mechanical drawing, that if you make a mistake on one of these, like if you leave off a dimension, or if you put a dimension in incorrectly, it can lead to a really costly revision, and that revision could happen out there on the construction site. And in the worst case, you could even have a failure of a structural system because you missed a dimension or something. Now, one thing that architectural firms are pretty good about doing is that after you make your drawings, the drawings will go to an architect or a checker, because they do not want to have a mistake out there. And so they're going to really check your drawings. And so they put a lot of red lines down, And so when you get your drawings back from me with a lot of red lines on there, I'm not doing anything that's not going to happen to you in industry. And that's part of the thing here, and the way we train you is that we want you to know there are going to be red lines, and you're going to have to correct red lines. And sometimes the red lines you're correcting were done by someone else when you're out there on the job. So just get used to the idea of making corrections to drawings. And there's even a term for it in industry. It's called making red black. And what that means is you're taking those red lines and turning them into black lines, when they're printed out. So you're trying to catch all of the mistakes. So what we're going to do in this class for the assignment we're going to work on today is we're going to talk about a few of the standards. There's not the standards are a little bit different in architectural drawings, how to apply the standards, how to dimension the guest cottage, and then later when you get to your capstone project, if you lean toward architecture, you can choose the architectural capstone project. And so that would require you then to do what you are going to learn in this chapter. You'll apply that again on the capstone. Pardon me. And so in doing that, what you would do is you'll make an architectural dimension style, and you will add dimensions to a much more complicated project than the guest cottage is. But the guest cottage is a good starting point. So a lot of times when you go to work for somebody, they have an in-house drafting manual, and it's the set of rules that they go by. And this is generally truer, I think, for small companies where they have the in-house drafting manual, and it was developed usually by employees or the principals of the firm. And this manual is used to, it helps them decide how to dimension things, what they name their layers, all those sorts of stuff like that. But I want to point out to you that there is a standard called the United States National CAD Standard. And this thing is gaining traction in industry. And so this would be, I guess, comparable to what we've seen with the ASME standard when it comes to mechanical drawings. And what's happening is that more and more firms are adopting this because when they get a contract to design something, a lot of times in the language of the contract, it will say that the drawings that the firm creates have to comply with the National CAD standard. So, firms, whether they want to use the standard or not, they're being forced to it, because when they sign the contract to design a building, and this is especially true if you design a school or a government building, that the contract will state that your drawings have to comply with the National CAD standard. So, man, first thing in the morning, I don't usually talk to anybody until I see you guys, so I apologize. So the National CAD standard was developed by experts from the fields of architecture, engineering, and construction, and it was an attempt to kind of standardize things. And so, for example, CAD layer naming conventions, and what those layer naming conventions are based on in the National CAD standard are the Aia Cad Layer Guidelines. Now, the AIA, if you remember from Chapter 1, is the American Institute of Architects. And so, they are trying to get everybody to name their layers the same way, so that when you open up a file that somebody else has created, that the layers are familiar to you, okay? Because there are like dozens of layers in an architectural drawing. Your plumbing's going to be on one layer, your electrical will be on a layer, your floor plans will be on different layers, elevations, everything is going to be on different layers. And so the AIA is trying to standardize that. So they've come up with like a algorithm for how you name layers. And what we do in this course is we're not using the AIA standard. It's really complicated. And so what we do, we wait until you take your first architecture course, which you can take next semester. And when I say architecture, I mean your first architectural CAD class that you can take next semester. And so after this course, I'll write it up here. It's DFTG 1417. This is architectural drafting for residential architecture. And this is where we talk about standardized names for your layers and things and get into that. So you will come into that later. You can take this course next semester if you finish 1405, which would be another good reason to finish those assignments in Chapter 5 so you can get on and focus on this architectural stuff. So what I did here is I just searched for the United States National CAD standard and found a copy or found a link to their site, nationalcadstandard.org. And just like with the ASME, if you've got a credit card, you can buy this if you want. Out there in an office, they're going to have it. You're not going to have to purchase it yourself, and we're not going to require you to buy it here. But once you get into more advanced architecture classes, we're going to be applying this standard more and more. So there's a term that we use now in architecture called building information modeling, and everybody calls it BIM. And you may have heard of BIM. I mentioned it a little bit earlier in the semester. And what BIM is it is like a smart model that you build of your architectural design. And then what you do when you need your two-dimensional drawings, like your floor plan and stuff like that, you just print what you need from the 3D model. And so in our classes at ACC, the first BIM class, and you can also take it next semester, I'll write it up here, it's DFTG 2431. Oh, DFTG 2431. Okay. And so our schedule is going to come out in a few weeks for next semester. And so if you're in architecture, DFTG 1417 would be a good course to take, and DFTG 2431 would be a good course to take. And then remember, there's also DFTG 1433, which is your basic mechanical course. And then there's DFTG 2430, which is the basic civil course. You can take all four of those courses next semester if you want. But anyway, you're qualified to take them by having 1405 as the prereq completed. Okay, so just remember that in building information modeling, we're building this 3D model, and then we're pulling our 2D drawings from a 3D model. And this is really the future of things. And if you stay in the architecture field, almost certainly you're going to be working with a software like Revit, which is a BIM modeler, or something similar to that where you can create a BIM model. All right. So I'm going to skip ahead here and talk about how, kind of what is the theory of dimensioning architectural drawings. Well, here's the thing in architecture. When we dimension a window, we don't dimension to the sides of the window whenever we're doing residential dimensioning. The reason for that is when you're framing using lumber, using wood, it's not very exact. And so you don't want to tell the carpenters, hey, it's exactly, 3 feet from this side to this side over here. So what you do instead is you dimension to the center of doors and windows. So I'm going to just sketch a dimension on here. And then you tell the carpenters how wide the window or the door is. And what they will do is they will actually frame it wider than they need it to be. And this is called a rough opening. Okay. And so, if we tried to tell a carpenter exactly how far it is from one side of the door to the other side of the door, and then when we get our actual door there to the site and try to fit it between those two 2x4 studs, that like right here, and there's one over here on this side, if the door didn't fit, that would be a problem. So that's why carpenters frame these things a little bit wider, and then they can fill in, and they use shims and things like that, and they'll fill in for windows and doors. So we have this thing called a rough opening size for a window and a rough opening for a door. And that is why we dimension from the centers of doors and windows instead of to the edges. Now, we saw last week when we were dimensioning mechanical that if we had a slot, we dimension to the sides of the slot in mechanical, and then we put a tolerance on there. But in architecture, you're not holding those tight tolerances usually. Now, having said that, when you're doing commercial architecture, and you may have window frames that are manufactured, from metal in a shop, those may be more exact, and you might dimension things a little bit differently if you're, doing something on a commercial building, depending on how it's going to be built. So anyway, so what we're going to do in this class is we're going to focus mainly on dimensioning to the centers of doors and windows, from the edge of the framing to the center of a door and then to the center of a window and so on like that. So you'll see that, but what I want to focus on right now is that rough opening that I talked about. So to give you an idea of a rough opening, let's say that the door we have right here is the front door to a house. Well, usually the front door of a house is going to be a 3-0 door. That means it's 3 feet 0 inches wide. To give you an example of the rough opening for a 3-0 door, the door will actually measure about 36 inches by 80 inches tall. So it's 36 inches wide by 80 inches tall. The rough opening width for that is usually 38.5 inches. So you can see that the rough opening is 2.5 inches wider than the actual width of the door, and that the height for the rough opening is 82 inches, even though the door is going to be 80 inches tall. Okay, so that's what I meant by, we kind of tell the framers, here's where the center of the door is, here's where the center of the window is. Frame it as a rough opening, and then when you actually get your windows and your doors to the site, fit them in there and see what you have to do to shim them up, or put in some little bit of extra trim or whatever it's going to be, so that you can mount the doors and windows in place. Okay, so so here's another example. If you have a 24-inch door, it would be a really narrow door. This would be an interior door for sure. Your rough opening would be 26.5, and your rough opening height would be 82 inches. Okay, so I want to remind you of something. When we say 3-0 on a door, for example, or a window, we're saying 3 feet 0 inches. If we say 2-0, it's 2 feet 0 inches. And if we say it's a 2-6 door or a 2-6 window, we're talking about 2 feet 6 inches. And usually what we use right here when we put in that 6 in this case, or the 0 up here, what we do, we'll just type 3-0, for example. We would type 3 and 0, and then we would double click on that text and we would highlight this 0, and in our text setting we would set this up for superscript, which is one of your options up there on your text editor tab. And so you would just change that 0 to superscript, and that's what puts it moves it up and it makes it a little bit smaller usually. So we'll use superscript for those. So here's a photograph of rough opening sizes on a place that's being framed, right? So we've got a door, rough opening, then we've got 3 windows in a row. Now the reason I included this is that there is a minimum amount of framing that has to go between 2 windows. So we have 3 windows here, and if you don't realize that it takes 4 2x4s between 2 windows, what you're seeing right here that's 4 2x4s. And let's say that you just say, oh, I only want 2 inches between those windows, and that's how you dimension it. You're going to get a call from the framers, and they're going to say, hey, we can't frame this with 2 inches between those windows. We need at least 6 inches between the windows. Now, it seems weird that 4 2x4s is 6 inches wide. Well, here's why that is. A 2x4, when we talk about a 2x4, if you measure it, it will actually measure about 1 1/2 inches by about 3 1/2 inches. So when we look at a 2x4 in the end view, so I'm going to just sketch the end of a 2x4. The distance across here would be 3 1/2 inches, and the height over here would be 1 1/2 inches. And so when we refer to something as a 2x4, we're talking about its nominal size. And so what happens is when they cut the wood for a 2x4, it's wet. The wood is wet because it's been, it was a tree not that long ago. So what they do is they cut it 2 inches by 4 inches, and as the wood dries or cures, it shrinks because it loses moisture. So by the time we're framing something, usually our 2x4s measure 3.5 by 1.5. So if you look over here in this photo, you can see there are 4 2x4s between each of those windows, and we're looking at the edge view of 4 2x4s. And so if you take 1 1/2 and you multiply that times 4, you're going to wind up at 6 inches. So 6 inches is the minimum spacing that you need between two windows, right? So don't embarrass yourself by putting less than 6 inches between two windows if you're using wood framing. Now, another way to embarrass yourself is right here, right next to the front door. Imagine that you're walking in the front door there, and what would you expect to find right there on that wall? Well, it would be your light switches, right? And if you design this house where you have a light switch that turns on the front porch light, and then you need another light switch that turns on an overhead light, let's say in the living room or the entry room here, and then you have another light switch that turns on a ceiling fan, what's going to happen is you're going to need an electric box that can hold each one of those switches. Okay, so you've got a switch. I'm drawing with my mouse, so I'm not very good. But imagine there's an electric box with a switch. Well, you would need 3 of those, to have that many switches right next to this door. And so you can see the distance between the framing right here. If you don't give the electrician enough room to put those 3 electric boxes in there, you're going to get a call from the electrician who's out there on the site and saying, hey, you didn't give me enough room to put 3 electric boxes there, but you show 3 switches right here to the side of the door. And then they'll say, what do you want me to do? Okay. So what are you going to do? Have the framers come back and move the windows or something like that? So these are the kinds of things, like some of you probably say, I want to be an architect. Well, it gets down to these little decisions like this. Those have to be right. And this is the small stuff. You think, oh, I want to, be like Frank Gehry and design beautiful modern buildings and all this kind of stuff. Well, even Frank Gehry has light switches. So somebody's dealing with those, and somebody's dealing with the, how do you make that building stand up? So there are a lot of decisions being made. And so I just want to point that out to you with this slide right here. So like this is the exterior of that same building. So you can see how wide it looks between each of those windows. And if you're an architect and you're thinking, oh, I want that really thin look between my windows, then you're not going to be able to frame these windows using regular lumber. And your cost is going to go up because you're going to have to use some kind of structural metal framing probably between. All right. So things just to think about if you want to be a designer. And the other thing is just, I'll point this out real quick, that when you walk up to this house and you walk up to the front door, and what this was, I actually designed this. This was a little cottage in a town called Fredericksburg, Texas, and it was a cute little cottage thing on a weird lot. This lot was only, I think, 45 feet wide, but it was 185 feet deep, and it had pecan trees. This picture was taken in the winter. So I designed it sitting 120 feet from the curb behind a bunch of pecan trees here. And so, it was just kind of a cute thing you might rent as a B&B or something like that. So here's the thing. When you walk up to that front door, which side do you want to have the door handle on? And which way should the door swing into the house? Okay. Well, the way it's going to swing is because there's a wall or something right here that it's got to swing in this direction right there, which means the door handle is going to be here on this side. So if you got that swing wrong and it swung into the room this way, so like when you walk up, the handle's on the left-hand side, or the right-hand side rather, no, it would be the left. You would actually, by swinging the door open, it would put your light switches behind the door. That would just be another little weird design thing that you've got to avoid, things like that. So there's so many little things, and you learn these as as you do designs, man, you make mistakes, and then you get smarter, hopefully, on your next design. So I'm just saying, think about the little stuff, visualize yourself in that space and using that space, and think through the whole thing of like walking into a room, where are the light switches, which ways are the doors swinging, where would you put the furniture in the room, and just all sorts of things like that. Okay. So here's an example of an architectural floor plan, and we've got some dimensions right here. We have a row of dimensions, and what they're dimensioning from is the edge of the framing to the center of the kitchen window that's right over the sink, and then to the edge of the framing, and then all the way across to the edge of the framing right over here on this side. Okay. Then we include an overall. So, we have 3 dimensions and an overall. If we were doing this in mechanical, we would have to make one of those a reference dimension. But in architecture, because things are not very exact, because your lumber's crooked and everything else, it's hard to hold really tight tolerances, so that's not as near as big a thing. But then I want you to look right up here along this wall. We have a window here, a 3-0 window. It says 3040. What that means is 3 feet wide, 4 feet tall. So we would see the height if we had an elevation view. We have another window next to it that's 3040. And then we have a 3-foot door that swings in this direction right there. Well, here are your dimensions. We actually are going to have to place our dimensions on the inside of the floor plan to get all those guys in there. Okay, so when you're dimensioning architecture, a lot of times you're just trying to fit your dimensions in where it's clear and people can read them easily. Okay, so these dimensions tell us where the centers of a 3-0 window, another center of a 3-0 window, and the center of a 3-0 door. And when this door swings open, I want to point something out to you. The hinge would be right there. And we actually call that side of the door the hinge jamb, Jamb. Okay. And so if you were on the phone with somebody and you're looking at the plan, they might say, are we looking at the hinge jamb on that door? Or are we looking at the strike jamb? This is your strike jamb, is right over here on the left-hand side. So the hinge jamb is on the right, the strike is on the left. That's where your door handle and everything would be. Right next to that, you can see these 2 S's. There's a S with a line through it. That's a switch. So that's what I'm talking about. You've got to make sure there's enough framing right here to accommodate 2 wall switches. This little circle with an X, that's an outdoor light. And then we've got a 3 and a 0 inside a circle. The 3-0, that indicates that that is a 3-0 door. Okay, 3 foot 0 inches door. All right. Let's see if there's anything else in here. I think I saw something. Oh yeah, right down in here. Here's some other things that you'll have on your floor plan. Each of these guys right here is a 120 volt outlet. So we're talking about a 120 volt AC. Now, depending on where you are, that could be 110 volt. It's somewhere in a range of 110 to 120 volt AC. That's what those are. So right here, we have an outlet for gas. We have a 120 volt outlet. We have a vent right here, because actually what happens in this little spot, there's a stackable washer and dryer that fits right there. So we need gas. We need 120 volt AC. And then also we need a 220 volt AC, a 220 in case we have an electric dryer. So these are some of the things that you have to think about. Right here, HB, what that stands for is a hose bib. That's an outdoor faucet. So there's an outdoor faucet located right there. And the reason why it's good to put a outdoor faucet right here is that we're going to have water, hot and cold water in this wall right here, because we've got our kitchen sink there. And we also need water to feed the washer and dryer. So by putting the hose bib there, we're putting it near where our plumbing is, that we're going to need to get the cold water to that outside hose bib anyway. So we're going to get more into things like this later in the semester. So the focus today really is going to be on putting dimensions in, of course, and not all this other stuff, but I just want to start pointing this stuff out to you. So I'm going to skip through this because I think I'm going to show you a lot of this stuff here in just a second. Here's an example of dimensions and notations added to the elevation drawings. So we've got some dimensions here saying, telling us how far these roof overhangs are. We have a lot of notations telling us about the stairs, and we've got a little porch right here, and we've got another porch over here. We've got an 8-inch post right there on this cabin project. So we've got cedar siding on the side of the cabin. Got a 6-inch galvanized iron flashing. So there are a lot of notations and things that go on, even on elevation drawings, if we're not looking at floor plans. The alignment of text on architectural drawings is this. Your text is going to face down, it's going to face the bottom of your drawing, and it's going to face the right. Okay, so unlike in mechanical where we had everything facing down, we're going to align our text with the dimension line. Okay. The other thing you're going to see, instead of an arrowhead, a lot of times you're going to see what's called a tick mark. This is called an architectural tick mark, that guy right there. Usually those are drawn at 45 degrees. AutoCAD has a setting for putting those in, and I'll show you that in just a little while. Now, one thing I wanted to show you guys, we ought to do it on, I guess I could do it on this one. If we were talking on the phone and I was trying to tell you where to look, I might refer to something. I might say, look on plan north, right? And when I say plan north, I mean, imagine that we've got a compass. And so this may not actually be the north side of the house, but if we're looking at our drawing and we imagine that we have a compass, north would be up like that, south would be here, and then we would have east and west. Okay, so if I said, okay, there's a dimension plan west of 1 foot 10 inches, well, this would be the west side of our plan, and that's what I would be referring to. So if I said plan east, I might say, hey, the refrigerator area is over there, plan east, and the hose bib is plan south on this. So just some more terminology for you. Okay. So we're going to skip over here and talk a little bit about dimensioning and how you space those dimensions. The National CAD standard gives you some dimensions that it wants you to use. It wants the first dimension to be 9/16 of an inch away from your floor plan. Then between this dimension line and this dimension line, it wants 3/8 of an inch minimum. Now, if we were doing this in the metric system, that would be 10 millimeters and 14 millimeters is what we would want. And you can see we have a little visible gap right here, and that usually is set to 1/16 of an inch minimum. All right. So what we have to do, though, is imagine when we put these dimensions on, that the actual distance we're going to place this dimension away from the front edge here has to equal 9/16 when this project is printed. But when we put our dimension in right there, in order to get 9/16 of an inch on the printed one, we actually have to space that first dimension 27 inches away from our part if we're drawing at 1/4 inch equals 1 foot. Now, that's kind of complicated for you guys right now, and we'll get into it more. But so what we're going to do when we draw the guest cottage is we're going to use at least 27 inches from here to here to place our first dimensions, and then we're going to use 18 inches to place the second row of dimensions. Uh-oh, little marker's acting funny. So the reason for that is this. When we draw the floor plan, we drew it full size. We drew it actually 18 feet by 15 feet. So if we went in there and we tried to put our dimensions 9/16 away from that floor plan, they would just be right on the edge of that floor plan right there. It would be like going out to the job site and putting your dimension in only 9/16 away from your foundation. So what we're going to do, we're going to put the dimensions. We imagine we're dimensioning on the job site. So we're going to place that first row of dimensions out there 27 inches from the sides of the house. And then for our second row of dimensions, we're going to go 18 inches beyond that. So because we draw full scale, when we draw a floor plan in model space, if we put our dimensions in model space, we have to also scale up, right? So what I like to imagine is that your floor plan is on a piece of property. And when you go into to dimension it, imagine you're going to go out there into the yard and you're going to use a can of black spray paint and you're going to spray paint dimensions on the grass. Well, you're going to spray paint your first row of dimensions 27 inches away from the house and your second row of dimensions 18 inches away from the first row. All right. So sounds kind of complicated, but it's not that much. So dimensions are placed from the outside face of the framing. The first line of dimensions locates interior walls and the centers of doors and windows. The second line of dimension denotes distances between outside walls and interior walls. And if you have a third row, a lot of times it's going to denote the overall distance between outside walls. Interior dimensions usually locate interior walls and other features from the edges of outside walls. And dimensions should be aligned with dimensions that read from the bottom and the right side. Okay, and dimensions should be centered above your dimension lines. The space between the outside of the building and the first dimension line should be 9/16, and it should be consistently applied on all sides of the house plan or plan you're drawing. And the spacing between succeeding parallel dimension lines should be 3/8 of an inch minimum, and that should be consistent. Dimensions may terminate in tick marks or arrowheads, and all your tick marks should be parallel. So if you've got a tick mark here and you have another dimension over here, you would want this tick mark to be parallel to that tick mark there. Dimension text height should not be less than 3/32 on CAD drawings. So that means when it's printed, your text height should not be less than 3/32 of an inch. When we put our dimension text height in our drawings, because we're drawing full scale out there on the job site, if I were writing in the dimension using my spray can, I would have to write my dimensions probably 3 inches tall. So I think we're setting ours to 3 inches on this. Dimension font style should be sans serif, which means usually that we don't have these little top hat things if we write an I, we don't do that. That's when we're trying to comply with the NCS. So like in the NCS, a good font, it would be like Arial or Tahoma or something like that. A lot of architectural firms, when they're drawing house plans, they will use a font that looks like architectural freehand lettering. And so we're going to actually use that on this plan. We're going to set our lettering to Stylus BT. Stylus BT. What that looks like is kind of architectural style of freehand lettering, and it works pretty nicely on these drawings, so you'll see that. All right, questions. That means we're at the end of what I was going to talk about there. And if anybody has a question, I'll take that. Otherwise, I'm going to project AutoCAD to your screen and show you about putting these dimensions on. Okay. So let me get up AutoCAD real quick. Here we go. And go to model space. So this is what your floor plan is going to look like once you have dimensions on it. Now what it should already have are like these circles with the A's in it, and those represent windows. And then you've got a 3.0 door, and if you recall, we have these windows marked as A's, or we've got one window up here marked as a B. And that is because, let me go to paper space. In paper space, we actually have a window schedule, and it tells us that anything that's marked A is a 3.0, it means it's 3 feet 0 inches wide, by 5.0 means it's 5 feet tall. So we don't see that unless we're seeing the elevation view. Our quantity is 4. And the type of window we have is called a single hung window, which means you can open it only in one direction. Only one half of the window opens. The B window we have here is 2 feet 0 inches wide by 2 feet 0 inches tall. So it's not a very big window. but let's look and see where it's located. It's located in the bathroom. And so it's kind of a tall window. It's not very wide. And in Chapter 9, we're going to come in here and we're going to add a tub to this. We're going to add a toilet, and we're going to add a vanity with a sink. The tub is going to go right over here. The bathtub will go here. The toilet is going to be here, and then the sink area is going to be in here. That's what we'll be working on in Chapter 9. So that's why we're going to dimension this in Chapter 6 and reopen it in Chapter 9. And so this window would be above where the toilet is going to sit. Usually in a bath, you have to have a vent or a window. Most people put in both. Okay. Now, in the closet, we're going to have a couple of interior dimensions. We're going to have this 1.00. And so if you recall in the closet, let me go into model space here. In the closet, we took this wall right here. Sorry, got more of the wall than I wanted to. We took that wall and we offset it 1 foot. And what that represents, that solid line we've got right there, is a closet shelf that would be like probably set up maybe about 6.5 feet, 7 feet high. Underneath that shelf, we've got this dash line right here that we offset 10 inches. And we did that all the way around. The dash line represents the clothes rod that you're going to put your hangers on. So we have a closet shelf and we have a clothes rod, and the clothes rod is dashed, and that goes all the way around. And just to show you what we're going to do, we're going to add a dimension saying that the shelf is 1 foot approximately. Now, so you would imagine that they're going to use a 1x12 when they frame that or when they put that shelf in. But keep in mind that a 1x12 is going to be 11.5 inches wide. So you're probably really not going to be at 1 foot on that. But the center of your closet door from this inside wall is going to be 3 feet 4 inches. Okay. So that we just tell them where the center is. Then we say there's a 2.0 door. So they're going to put a rough opening here. So instead of framing that 24 inches, because it's 2 feet wide, they're going to frame it 26.5 inches wide. And then when they get the door is actually going to come in with a door jamb around it, and they're going to put it in. That's why it's got to be wider for one thing. But we're also telling them that when you hang the door, we want the door to swing outward. We want the hinge jamb to be over here, and we want the strike jamb to be on this side. So later we're going to add a ceiling light in here, and we're going to put a switch right here on this side that will go to that ceiling, that overhead light. If we put the switch on this side and you open the door and you walked in the room, it would be kind of awkward because the way the door swings open, the switch should be on this side and not on this side over here. All right, so we're going to place all these dimensions in here. So what I'm going to do is click on this guy here. So here's how you're going to start. First off, everything I've talked about is in Chapter 6, but if you look on page 313 in Chapter 6, you can see the sketch with all the dimensions. And this is the same sketch that you used in Chapter 4 a couple of weeks ago when you drew the floor plan. Okay, so if you want to look on page 313, this is Guest Cottage Project 6.1. Kind of hard to believe we're on page 313 in the book. So every dimension that you see on page 313, you're going to want to make sure that you get it onto your Guest Cottage project. So that's where I would recommend using your marker again, your highlighter, and highlighting each dimension as you put it into the AutoCAD drawing to make sure that you get them all in there. All right. So if you look on page 314, you can see you're going to create a new dimension style called Arc 24. That's at the top of page 314. So remember, the way we start a new dimension style is we go to our dimension toolbar and we pick on this bottom tool right there. Pick on that, And I already have ARC 24. You won't have ARC 24. You will have standard instead. So you will pick new. And what will happen is it will take your current settings, which are in standard, and it will say copy of standard. And right here, you would type ARCH 24 and pick continue. All right. Now, I'm not going to do that because I already have mine set, but that's what you're going to do. So you would, standard would be highlighted, you'll pick new, and then you'll go create ARC 24. So I want to show you the settings for ARC 24, and you can see those when you look on page 314 and 315. And then there are some directions on page 316. But it tells you in the book that the first tab to start with is actually your primary units tab. And what we're going to do, we're going to set this to our precision to 1/16 of an inch. So mine's right now for some reason set to 1/2. I would want to set that to 1/16. And I just want to go through and I want to make all the changes that I'm seeing right there. I think we also put all these in Blackboard, so you'll be able to see these in Blackboard as well. You'll make your changes here, and the next tab it says to go to is symbols and arrows. And this is where you're going to select architectural tick, which are those slashes right there. So you're going to pick architectural tick. You want that for your first and your second. And what that means is, you know, there'll be a tick mark at the first part of your dimension. There'll be a tick mark at the second termination of that. If you have a leader, you're going to have an arrowhead. And we're going to set the size of the tick to 3/16 of an inch. All right. And then we're going to go to the top of page 315. We're going to switch over to lines. We're going to pick on lines. And we're going to go through and we're going to set these settings that it has in here. And you can see these look small. They're like 3/16 or 3/8, 1/16. And a minute ago I was saying, well, we're going to set some of those things 18 inches and 27 inches. You're going to see how we're going to address that in just a second. So then we pick on text. And for our text height, we want that to be 1/8 of an inch. And we want it to be standard. And the standard font in this drawing is already set to stylus BT, and I'll try to remember to show you that. But so we're going to text height's going to be 1/8 of an inch. Well, that's like the size of an ant out there on the job site. So what we're going to do is we're going to scale that up, and I'm going to show you how that happens here in just a second. And then the last tab is the fit tab. We pick on the fit tab, and we're going to check what it shows on page 315. But then right here, you see where it says use overall scale of? We're going to type in 24. That's why this dimension style is going to be called ARC 24, because every setting that we've put in there is going to be scaled up times 24. So if we have 1/8 inch text height, we're going to multiply that times 24. And so what we're going to end up with is 3-inch tall text when we put our dimensions in. Our tick marks, which we set to be 3/16, they're going to get multiplied times 24. Every spacing that we have is going to be multiplied times 24, and that's where we're coming up with this ARC 24. So that's in your fit tab. If you don't do that, everything is going to look minuscule. It's going to look, you're not even going to be able to read it. Everything has to be multiplied by this 24 right here. Okay. At that point, you pick OK, and then you want to set ARC 24 current, and then you can close. The next thing you want to do, I'm going to press escape. I'm going to go to my home tab right here. I need to make a layer, and I've got a layer named dim. I think it says in the book to make a layer called dimensions. You may have already made that, but make a layer named dimensions and set it current. It should be default line weight. The other thing you want to check is go to format and go to text style and make sure you're set to stylus BT. and then for your standard text style. We can close that down. All right, so let's place the first row of dimensions. So I'm going to use my linear dimension, and I'm going to go from here, I'm going to pick there, and let's say that I want to go to the midpoint of that window right there. I'm going to pick, and then I'm going to move out. Now, how far do I move out? This is that thing I was telling you about where you want to move out 27 inches. So one way to do that would be to drag everything up and set it right on your exterior line, and then pick and hold down and drag it and type 27 and enter, like that. Another way to put that in, and a lot of people like to do this, is they like to do an offset. So you pick offset, and you set your offset distance to 27, and you press enter, and you take this front line and you offset it 27. Then what I would do is do another offset and type 18 and press enter, and offset this 18 like that. Then I would pick on those and just drag them out a little bit. Just makes them easier later because these are construction lines, we're going to erase those later. So now what I can do is put my dimension and put my first dimension right on that line, and then put my second dimensions on this line here. So I'm going to show you a trick that you don't know yet, and this is going to be worth tuning in today if you watch this. So the first dimension we're going to put on here is going to go, we're going to use a linear dimension, we're going to go from this corner, and we want to go to the midpoint of that door. But because this line on the front edge, sometimes that line runs all the way across, it doesn't find the midpoint of that door. That midpoint right there is the midpoint of the line, but it's not halfway between this door jamb and that door jamb there. And remember, we want a dimension to the center of a door and the center of a window. So what you do is you can hold down your shift key and right click your mouse and pick right here, mid between 2 points. Now it's going to show you this in the video. So it says, okay, well, where's the first point that you want to pick between? It would be at this jamb right here. This is the hinge jamb. And then it says, where's the second point? That would be at the stripe jamb. And look right there, it found the midpoint between those two. And then you come right down here and you pick, and you place your first dimension 27 inches out from there. Now, I placed that using a linear dimension. So I'm going to do it one more time, but I'm going to do it real quick this time. I'm going to pick on linear. I'm going to pick right there, and then I'd say, oh, well, I want to snap between the two jambs here, and it's not working, so I'd hold down shift and right click, pick mid between 2 points, pick there at the two jambs, pick down here, and pick right on the 27 inches. All right. Now what I want to do, instead of going back to linear, I'm going to use the continue tool. See this guy right here? And you can also get that, I think you can get it up here. I don't see it, so you are gonna have to get it from right here, I think. And now what you want to do is you want to snap to the midpoint of that window. And then you want to snap to the midpoint of this window, and you want to snap and pick at the midpoint of that window, and then you want to pick over here at the corner of the framing, and then press escape. Now, see how easy that was? So the first one we used a linear, then we used continue, and we snapped. The reason we could do that is because the way that we made these windows, you may not remember it, but when we made the windows, we used the rectangle command, and we picked, and we drew a rectangle that was 36,4 and pressed enter. So if we snap to the midpoint of this front line, we'll be right at the center of that window. And then what we did is we drew a line from the midpoint on the side to the midpoint on the side, and that's how we designed these windows that we have in here. So that's why we were able to snap to all of those guys. All right, so now what we want to do is put a dimension on that shows the overall width of the house. So we pick on our linear dimension, and this time we're going to pick right at that tick mark, and we're going to pick at this tick mark here, and we're going to come down and we're going to line it up on that line that we offset 18 inches. Remember, we offset the first one 27, this one 18, and press escape. And then what you want to do is delete both of those lines out. And there you go. There's your first set of dimensions. Here's something some of you guys are going to have to do. You're going to have to use the move command, and you're going to have to move this so that the dimension doesn't run through it. Okay? So the way you use the move command again is you pick on move and it says select objects. You would pick the letter and the circle and then press enter. Then it says specify a base point. A base point is like a handle. You could pick right in the center or you could pick out here. And then you're just moving it relative to that handle right there. So you just move to the left a little bit in this case and pick so that this dimension doesn't run through there. If your dimensions run through those, I'm going to mark those with a -1 if you do that. Okay, so we need a row of dimensions going up the side right here. And so I would start by doing the same thing with my offset. I would go up and do an offset, type 27 and enter. And I would zoom in, I would pick on this line and pick out there. So there's the location of my first dimension. I would do another offset and I would type 18 and enter. And after this, I'm going to turn you guys loose. I just wanted to show you how to run a set of vertical dimensions. So I'm going to drag those out so it makes it easier to erase them later. Okay, so what I want to do in looking at the dimensions that I need to have on that side of the house, which is on page 313, I have 3 dimensions that go over there. I would pick on linear. I would pick at the corner of the house right here, and I would pick at the midpoint of that window, and it finds the midpoint, and then I would come out here and I would pick right on my first offset. The next thing I would do is I would do a continue, which is this guy, and it picks up right where the last one ended, and this time I'm going to go over here and pick right there and press escape. And then I'm going to do another linear, and I'm going to go from the tick mark here to the tick mark on that side. I'm going to place it 18 inches over, and then I'm going to erase both of those guys. Pardon me. I would do the same thing on the top and the right side views. And you can see those dimensions on page 313. And I also need to add these dimensions that I showed you in here. And so to place this dimension halfway between this door jamb and this door jamb, what I would do is I would pick on my linear dimension. I would pick at that corner right there. I would move over, and then I would try to find halfway between there. Well, what you do, you hold shift and you right click and you pick mid between 2 points. You pick the hinge jamb and you pick the strike jamb, and AutoCAD will find the midpoint between those 2 jambs and place it for you. And again, all of this is going to be shown again to you in the video. So there's one video that shows you how to make your dimension style, and there's one dimension that shows you how to place all the dimensions. You need to add one note on this, and remember your text height here is 1/8 of an inch times 24, so this is 3-inch text height. So when you put your note in, you would go to text. I would use multi-line text, and I would draw a rectangle like that, and you can see that it's blinking right there, and I would type notes. I would do all caps. Come on, all caps. And a colon and a space, and then I would type wall thickness and so on. And here's the deal. You highlight that, all that text, and look right up here. Well, mine says 8 inches. So what I want to do is pick in there and type 3. And I want to make sure it doesn't put 3/8 in. I may have to back off. I want 3, and then you have to press enter. When you do that, this is going to change to be 3-inch text. All right. So you'll see that. And so when I click on my layout, that text needs to be right down there. And so here's the title block that we have on this. All of this is in paper space. And so this is what you're going to be writing is 1/4 inch equals 1 foot. You may have already filled that out. I don't remember if you've got all this filled out or not. But that's what it will look like when you're done. Except you'll have dimensions on the sides. Let me go to what it actually looks like. This is what it looks like in model space when it's finished. And this is what it looks like in paper space when it's finished. You don't need to print this one because we still have to add the tub and all that other stuff to it, and that's going to happen in chapter 9, and this is chapter 6. So you just want to dimension it and save it. You should have this done before Wednesday at 11 o'clock if you want to be on schedule. And this doesn't take very long to do. Like I said, you can usually dimension this in an hour, hour and a half. Just watch the videos. And so I'll go to Blackboard and just show you where everything is. You'll click on your Chapter 6 curriculum. It will take you here. And so there is a video on dimensioning basics that's similar to what I talked about. There is a PDF on dimensioning architectural drawings. There is a quick reference for architectural dimensions. And if you remember when I was talking with you guys at the very end, I kind of laid out some guidelines and stuff. So that's what we have there are those guidelines and as a PDF. And then the Guest Cottage PDF right here for setting up your ARC 24 dimension style. Now, I want to point something out to you is that when this class ends, at some point they're going to turn off Blackboard for you guys. And that'll be next semester. You won't have access to this Blackboard anymore. You'll still have access to the links that are on YouTube for those videos. But if there are any of these PDFs you want, you should save those. You should download and save those so that you have those next semester. So just something I want to point out to you guys. And that's true for any of these chapters that you have. Then you have an assignment. It tells what to do. You're going to read through 306 through 311, blah, blah, blah. Then it's going to tell you how to put all these guys on. But mainly you're going to pick right here on the assignment folder. And it talks about, there's a video for the Guest Cottage assignment right here. Then there is a video on dimensioning the Guest Cottage, and there's a video on creating an architectural dimension style. So you have videos for everything you need on this guy, and it says we will print this later. So with that, I'm finished. So I'm going to open it up to you guys. If you have a question, about chapter 5, stick around and talk with me about that. But it's really important you finish up those chapter 5s and get those into me and get those grades in place and get this done before Wednesday, because on Wednesday we're going to start a new assignment. So, that's the pace of the course now is things are moving a little bit faster, but like I said, this doesn't take very long to do. All right, so if you're leaving, I will see you later. And if you're sticking around, I'll be on here until 12:40, and it's 5 minutes after 12 right now. So if you have trouble printing chapter 5, let me know. I can help you with that. Dimensioning chapter 5, anything you've got, or anything on this right here. Okay, thanks. Have a great day. And I will see you on Wednesday at 11 o'clock if I don't see you before then. Thanks. Bye.